Hi, CPLs 1. This is our fourth video, solving linear equations. I should be taking notes on this, okay? Let me get that out of the way. All right, we're going to have some fractions, but hopefully by the end of this video, I'm going to show you a technique that is going to help you along in all math classes from here on out. All right, so let's perform the indicated thing. So if I want 4 times 1/4, notice the 4 down here, those cancel out, so I just wind up with x for an answer. In this one, the 8's cancel out, but I am left with 3x for an answer. This one, the 11's cancel out. Notice I have a negative. That still needs to come in, so I get negative 2x for an answer. The 7's cancel out, so I'm left with 4 for an answer. If I'm adding fractions together, okay, we had common denominators back in the day, right? I'm going to show you something that is going to be a little bit of a trick. Okay, and it works every time. So let's say we have a over b plus c over d. If I wanted to add those together, I'm going to go a times d, keep the sign, plus c times b, all over b times d. So if those were numbers, let's utilize that up here. A times d, 1 times 5, 5, plus 1 times 2, 2, over 2 times 5, 10. Uh-oh, I get 7 over 10. Why did I never learn that way? I apologize. But please use that. It's a great technique for adding and subtracting. Notice it works with subtraction as well. I go 3 times 4, that's 12. I'm going to have that minus there, though. And then 1 times 7 is 7 over 28. 12 subtract 7 is 5. 5 over 28. Wait a minute. Does that work every time? Yeah. Yeah, it does. Sorry that you didn't learn it. I apologize for your elementary school teachers that didn't teach that way. Keep doing it. Cross it. 2 times 5, 10. The minus sign, so bring that down. 3 times 3, 9. Over 3 times 5, 15. 10 minus 9 is 1, so I get 1 over 15. Done. Wait, that's so much easier than I've ever seen before. I know. 1 times 2, 2. It's plus, so bring the plus down. 3 times 4, 12. Over 8. That's going to give me 14 over 8. Uh-oh, we have to reduce this one. 2 goes into 14 7 times, 2 goes into 8 4 times, so I get 7 over 4. So sometimes you might have to reduce, but that's just fractions for you. But I don't want you to fear them. This is a great technique. We'll look at it a little bit more in class as well. I'm just going to skip this page because I'm not really sure what I wanted to fill out on it. It's kind of put it in afterthought. Okay, so remember, if you have parentheses, make sure you distribute. So this one we want a times b to get ab, a times c to get ac. So remember, when you have c parentheses, make sure you distribute over the parentheses. So let's do exactly that. It's 3 times 3, so that's going to give me 3k plus 24 equals 21. Notice I didn't bring that all the way over. I just took care of what was on the parentheses. And from there, we're going to go ahead and solve it like normal. There's my dotted line going, meaning the equal sign. So I'm going to subtract 24, cancel. 3k is equal to 21, subtract 24. You have $21 in your pocket. Something costs $24, still owe 3. Divide by 3, divide by 3. Those cancel. K is equal to negative or negative. It's going to be negative 3 over 3 is 1. There we go. There's our answer. Okay, here's the little trick sometimes. What do we need to make sure we distribute over the parentheses on this one? Do I distribute just the 2? No, I distribute the negative 2. Notice I didn't go 6 subtract 2 first because the order of operations wouldn't allow us to do that. So the 6 has to come down. Negative 2 times 3x is negative 6x. Negative 2 times negative 5 is positive 10 equals 40. These are like terms, so I'm going to go ahead and combine those together. So that's going to give me plus 16. Notice I didn't put it over. I just combined like terms that were on the left. And now we should be able to work out our problem. Subtract 16, subtract 16. Negative 6x is equal to 24. Divide each side by negative 6. Those cancel. I'm going to get a negative answer. 24 over 6 is 4. So negative 4 is my answer. All right, fractions. Oh no. Well, we just kind of saw a new fantastic way We're not going to necessarily do that on these because what we're going to do is we want to get rid of the fractions. Okay, so let's think about this. What number do 3 and 2 both go into? Did you say 6? Heck yeah. If you said 6, you're totally right. Okay, so I'm going to multiply this by 6 over 1, this by 6 over 1, and this by 6 over 1. Notice I did all the terms. So then 3 goes into 6 twice. 2 times 1 is 2, so I get 2x because the x was there, plus 2 goes into 6 3 times. 3 times 1 is 3, equals 3 goes into 6 twice. 2 times 10 is 20. What no longer exists on our problems, my friends? Got that right. No fractions. This is going to work out the exact same way. Even if you worked it out really with the fractions, or if you did it this way, same answer. This way makes a lot more sense. It's called clearing the denominator, and it's great. So the 3, I subtract 3 from both sides, so I get 2x equals 17. Divide both sides by 2. Does 2 go into 17 evenly? No. So 17 over 2 is a reduced fraction. And just leave it just like that. Don't turn it into a mixed number. So let's apply that same principle. So I have all the same denominators up here, agreed? Well, it's going to work the same way. I'm going to multiply this by 15 or 15 or 15. I could have put them all over 1. Those cancel, so that gives me A. Those cancel, so that gives me 4. Those cancels, that gives me 9. Oh my goodness, this question looks so simple. Subtract 4, subtract 4. And we're done. Those cancel. A is equal to 5. Guess what I didn't have to work out? I didn't have to deal with the fractions. So what do we do when we want to clear the denominator and we don't have everything with a fraction? Well, that's okay. Ready? That's a fraction now. Okay, just put it over 1. So what's the smallest number that both 3 and 4 go into? Yeah, you're right, 12. So I'm going to multiply this by 12, this by 12, and this by 12. And we're going to start reducing. 3 goes into 12 4 times. 4 times 2 is 8. This one won't reduce, so I just wind up with 12y equals, and then 4 goes into 12 3 times. 3 times 3 is 9. Okay, let's start working this out. Subtract 8, subtract 8. 12y is equal to 1. Divide each side by 12. And now then, smart notebooks in the way. Let's move that. There we go. Those cancel. Y is equal to 1/12. Cool. And I didn't have to deal with the fractions when I worked it out because I cleared the denominators, the bottom number. Okay. So what do you think you want to do on this for next one? Definitely says distribute. Agreed? I guess we could distribute. Yeah, that wouldn't be too bad. So let's go multiply here. So 3 times 1/2 is 3 over 2. And then the x comes out. What's half of 6? Yeah, it's 3. Equals 9. Now, I didn't have to do that half all the way over to the 9 because I was just dealing with the parentheses. What do you think I should multiply everything by to get rid of the denominator? Yeah, 2. That's my denominator. That cancels, so I get 3x here plus 6 equals 18. Okay. Subtract 6 from both sides. 3x is equal to 12. Divide each side by 3. So x equals 4. All done. Not too bad, my friends. All right, I think this might be the last example, I think. Oh, looks like we have a total of 3 more problems. We'll get through it. All right, so what do you think, friends? We have a denominator of 2 and a denominator of 3. What's the smallest number that 2 and 3 both have in common? Or both going to? Yeah, that'd be 6. So I'm going to multiply all my terms by 6. Then I'm going to start reducing. 2 goes into 6 3 times, so 3 times m is 3m. Plus, because there's a plus sign. 3 goes into 6 twice. 2 times m is 2m. Equals 6 times 1, which is 6. Combine my like terms. 5m equals 6. Now I'm going to finally start doing stuff to both sides. Divide by 5, because 5 times m, to get undone, we divide. So I get m equals 6 over 5. There's my answer. Last 2 problems. And make sure if you have something that wasn't gone over really clearly on this video, write it down in your notes and we will go over it once we have class again. And happy to help you on it, okay? Okay, number 7. We have two different denominators in our problem. We have a 4 and we have a 5. What's the smallest number that both 4 and 5 go into? Just say 20. I think you're right. So I'm going to multiply all of my terms by 20. So 20 times 2 is 40. There was nothing to reduce on the first part. That goes into there 5 times, so that becomes negative 5m because it was 5 times 1 equals 1, that's a 4. 3 times 4 is 12. All right, now we're ready to start solving it. Clear the denominator. Let's solve away. Let's subtract 40 from both sides. Those cancel. You have $12 in your pocket. Something costs $40. How much do you owe? Just say negative 28. If so, you got it right. Divide each side by negative 5. Negative over negative is positive. 28 over 5 does not reduce, so I'm just going to get this for an answer. Done. All right, last problem for this lecture. We have two denominators. We have a 3 and a 2. What's the smallest number both 3 and 2 go into? Just say 6, because you got it right then. So 3 goes in 6 twice. 2 times 2 is 4. The G comes along for the ride. Plus 2 goes into 6 3 times. 3 times 1 is 3. And then 6 times 14. What's 6 times 14, friends? If you don't know it, grab a calculator. It's 84. Combine like terms. That's 7G equals 84. Notice I haven't done anything over both sides. All right, divide both sides by 7. So G is equal to 7 goes into 8 once, 1 left over. 7 goes into 14 twice. 7 times 12 is indeed 84, and so G equals 84. That's all we have. Make sure you write any questions down and complete the problems on here. Have a great day, everybody. Take care of one another.